Welcome to today's episode of the Aspire Ed Talk podcast. Today's title is Genetic Testing of Embryos and How Has That Changed? I'm your host, Arthur Chang. I'm professor at the University of Texas Health Science Center in San Antonio, Texas, and a proud representative of the Aspire Education Committee. Today, we are honored to have with us an exceptional guest, Professional Richard Choi. Professor Choi is the chair of the newly formed Aspire Reproductive Genetics Special Interest Group. He's a professor in the Department of OB-GYN and the founder of the PGT Lab and the Prenatal Genetic Diagnosis Center at the Chinese University of Hong Kong, serving now as a deputy director in charge of the lab services. These two centers are the leading tertiary referral and training centers for PGT and prenatal testing in Hong Kong, mainland China, and throughout Asia. In 2021, he established the Fertility Preservation Research Center to enhance IVF outcomes. As a pioneer in PGT and prenatal diagnosis, Professor Choi's team utilizes state-of-the-art genomic technologies, including the chromosomal microarray analysis and genome sequencing. Recently, his team pioneered a novel application of low-pass genome sequencing, a method which can detect balanced chromosomal structural variants or rearrangements that contribute to human diseases. It was the first reported outcome of a multi-center mosaic embryo transfer pregnancy outcome in Asia, and the contribution of pathogenic chromosome copy number variants in fetus with high knuckle translucency. Professor Choi has over 240 publications in international peer-reviewed journals, with several landmark papers uncovering the contribution of CNVs in fetus with structural malformations, and he has an amazing H index of 47. He serves as organizing committee member in 7 international professional and academic meetings. He is a vice president of the Hong Kong Society of Genetic Counseling and a board member of the PGT-IS, the International Society for Prenatal Diagnosis, and the Hong Kong Society of Medical Genetics. Join us as we discuss the exciting advancements in reproductive genetics with Professor Richard Choi. Welcome, Professor Choi.
Thank you, Professor Arthur Chang, for the kind introductions. It's my honor and privilege to be here to share some of our experience with the audience.
Myself, I'm an embryologist, so we are usually on the user end of this genetic testing reports, and oftentimes we can see the results, but more often we are also confused by the reports many times. And especially nowadays, there's a mosaicism, euploidy, aneuploidy, and all those controversies. And first, I would like to ask Professor Choi about the historical context, how the genetic testing has evolved to today's technologies in the IVF world.
Oh, thank you. So actually, genetic is amazing, although, it only carries the 4 characters, ACTG. But you can see since in year 1989, where we have the first PGT case in London by Professor Alan Handyside, there have been amazing changes over, the technologies in the last 2 decades, right? It's actually all thankful for the wonderful work of embryologists like you, because you can see that what we need to get the DNA. So without a very skillful embryologist, there's no way we can do that. So apart from, getting the cells, there are 2 other very important milestone development, okay? In early 2011, we have been moving from the conventional FISH approach to using a new technology called microarray, which is a comparative hybridizations, which we compare the test sample's DNA with a control to see whether there is a gain or loss of signals. So what is that means is that in that regard, in the old days when we do the PGT, particularly our first interest is to looking into the net gain or loss of the whole chromosome copied in a single cell at the blastomere stage. Then we need to use many different fish probe, right? Because we have 23 pair of chromosome. That is, very difficult to do. But with the microarray, actually we can do a single reactions and then able to see all the copy of the chromosome. So this is the first big jump. The second big jump is that massive parallel sequencing also happens in that time. So in 2014, we have started to move from the microarray to next generation sequencing, which is an even more powerful technology with cheaper cost. So with this improvement in terms of molecular genetic technology, we have been speed up and then be very costly to move on for PGT testing. This is why it drives nowadays we can do no matter on day 3 or day 5 biopsy, we're able to assess the whole copy number of chromosome. And this is what we call now pre-implantation genetic testing for antibodies, PGT-A now.
Fantastic. So I still remember like in the old days of doing the fish, we have to kind of make sure the humidity is good, and we have to blow the slides, like a breeze on the slides, and oftentimes we just couldn't get a good reading. So let's talk about the current technologies. Yeah, we don't have to do fish anymore. So what are the major technology being utilized for IVF nowadays?
Yeah, sure. So as we have mentioned, now we are moving to the era of pre-implantation genetic testing. Then in terms of genetic disorder, actually there are 3 groups, right? One group we just mentioned is that we have a gain or loss of chromosome copy number that is mainly lead to either the fail of implantation or early miscarriage or a unsuccessful pregnancy. And then there's a second group of disease which we call a chromosome rearrangement or even microdeletion syndrome. Like, in the pediatric cases, we have DiGeorge syndrome, which is in chromosome 22q11. This group of disease mainly because we see that there are rearrangement in the chromosome. That means maybe a long arm of one chromosome, they are translocated to another arm. They are sort of a balanced one. But then when they propagate for their next generations in the sperm or oocyte, they lead to an imbalance. So this is another scenario that will cause, miscarriage or, birth defect. The third type is that we know that, we have a lot of Mendelian disease. So these are rare disease, but it's only contributed by single point mutations. So the technology have been changed a lot in the last 10 years. It's mainly because by doing the massive parallel sequencing, now we can see each nucleotide very clearly and with confidence. So with that, actually our technology or the test categories for the PGT have been moving from the old days only we called it as PGS, which is pre-implantation genetic screening for chromosome, or PGT, which mainly focus on monogenic disorders, to now we have categorized them into 3 different groups. PGT-A, which I have just mentioned, is mainly to look at to antibody, or even because of the increase of the sequencing resolution, we can go down to 10 or 4 million base pair. The second one, the PGT-SR, structural rearrangement, which I mentioned, with the amazing technology of the sequencing depth, we are now able to even help the couples to identify those embryos that they are also a balanced translocation carrier compared to a normal embryos. Okay, and the third one is the monogenic disorder. As I mentioned, even for monogenic disorder, some could be just 1 point mutation, some could be a few base pair deletion, some could be a small insertions. And thanks for this new technology, including the next generation, or even nowadays, we have the long read sequencing technology. We can very confidently can call this kind of change, and we refer this as a test of PGT-M, which is pre-implantation genetic testing for monogenic disorders.
Yes. So those PGT-A, PGT-SR, and PGT-M are among the most frequently ordered from the IVF labs. I think usually in most cases, the PGT-M and PGT-SR, they are reserved for those who really require those testing. And however, the PGT-A has been like a widely used and in some cases maybe like beyond its original scope of use. So would you like to talk more about that, the clinical impact, like a decision making on the PGT-A, as well as the highly debated topic of should we do PGT-A for all cases?
Yeah, thank you. Actually, it's amazing that, after this new technology for PGT-A, it changed a lot of the thinking, not just for the clinicians, embryologists, laboratory director, but also on the patients. Because one of the main driving force from the earliest data is that by doing PGT-A, we were able to select embryos that do not have an abnormal chromosome number. So in that sense, actually, it increased the possibility to have a successful implant and also a successful pregnancy. And there are many multi-center study data have shown that they are really, promising for women with advanced maternal age. But for women, they are at the young age group. That means those are younger than 35. Currently, a lot of data is still very controversial. That means that is the intervenes of PGT-A is important for the young age group is still controversial. And why is that? Is because first, you cannot only do PGT-A, you need to do an invasive biopsy. Okay, so that is where there are possible of harms. Second, the PGT is still a very advanced technology, so the test cost is expensive. So this is the controversial. We have the technology, but is it really indicated for every woman? Is not. I mean, like our Aspire, special interest group and a lot of other special interest group. Most of the professional opinion do recommend PGT-A for advanced age women, and also they have indications of recurrent miscarriage, rather than applying this technology for everyone. Any women go for IVF.
One of the arguments promoting PGT-A is that it can shorten the time to pregnancy and also live birth. Is that true?
It's as I mentioned, right? It really depends on the group of patients, right? For those really advanced maternal age group and have been suffering with recurrent miscarriage, yes, the PGT-A is really helped to shorten the cycle time and then enhance the clinical pregnancy. So I mean, there still need a lot of more research to prove whether this could be the best way, because at the end it's invasive. Of course, there are other new technology. For example, there are new technology called non-invasive pre-implantation testing for antibody. Particularly, in some group in Europe, they have been doing a lot of this kind of new trends of the world. It's promising, but they also have their limitations. For example, there are still because you are taking the cell-free DNA from the culture medium that's surrounding the embryos. So there are still about up to 10% of possibility there are presence of tubercular cells. That is from the maternal cell. So they have maternal DNA. So this is one of their limitations. But of course, it's non-invasive, but still is an expensive test. So to answer your question in short, if we have new technology that's cheaper, non-invasive, and reliable, I'm sure that will be the way where PGT-A will be beneficial for all, right? Of course, there are also other new research coming up, only a few papers that actually you can also measure the metabolite, right? Because when the embryo growth is more like us, right? When you're well, your appearance, your physiology, is great. But when the embryo is sick, right? Maybe they have, genetic defect and other thing, then their metabolite is different. So there are other group of research also look at the metabolites of the culture media, and this is also regarded as another way of non-invasive, measurement. Of course, the third one is that there's a lot of work that we're using the time lapse where we can monitor, sequentially on different time points to look at the embryo development and to predict, whether the morphology of embryo can reflect, the outcome of live birth rate. And these are all promising technology. But at the moment, I mean, most of the data is still a bit controversial. So that will be the field that, what we are going to move forward in the future.
And those are excellent points. So one of the most frequent questions we have is how to deal with the mosaicism and utilizing embryos report as a mosaic and aneuploid. And what's your suggestions?
Oh, thank you. I mean, that's the great challenge. I mean, the good thing for me to work in a lab, both take care of the pre-implantation genetic testing all the way to the prenatal diagnosis, is because we understand there's issue of mosaicism. When we're talking about mosaicism, that means, when we samples a population of cell, there are different cells representing a different genetic makeup. Right. For example, if after yourself as an embryologist, right, we take about 8 to 10 cells. In this 8 to 10 cells, maybe 2 or 3 cells, they are trisomy 21, but the rest are normal. So this is what we mean by mosaicism. This mosaicism is difficult to tackle at the moment because first, as I mentioned, when we do the biopsy, we only take a few cells. So the mosaics of the whole embryo may be different from what we are, so we can only do an estimation. Currently, in the professional guideline, we recommend report, at a range about 20 to 30% to 80% in that regard as a mosaic embryo. And in terms of pregnancy outcome data, we have been shown that even for mosaic embryo, there are possibilities that they can rescue. And there are also data show that there are live birth outcomes, even with a mosaic embryo transfer. So I think in this regard, there are two important things. First, we need to understand the limit of the technology. Second, genetic counseling and also prenatal diagnosis is very important because only be able to do the amniocentesis, we are able to ensure that whether the fetus have been carrying the mosaic or they have been able to be excluded from the presence of mosaicism.
And that's very excellent insight, especially from the experts like Professor Choi, who serves both the pre-implantation and the prenatal diagnostic labs. So those embryo self rescue correction is a fascinating topic, which definitely worth further exploration. And today, it's our honor and we are very pleasant to having this chat with Dr. Richard Choi, and definitely with this exciting advancement in PGT as well as prenatal genetic testing. I believe we'll have this conversation even more often in the future. Thank you all for watching and listening to this ED Talk. And we are looking forward for a future episode. Thank you. Thank you, Professor Choi.
Thank you, Professor Alpha Chen.